Hello, welcome to mathematics lesson. My name is Kingsley Linus. In today's maths lesson, we'll be learning about highest common factor. By the end of this lesson, you should be able to identify factors of whole numbers and find the highest common factor, HCF. Factors are numbers we multiply together to get a certain number. A number can have numerous factors. These factors can either be positive or negative, but they are never fractions or decimal. Now, what do I mean? The number 12, for example, has factors like 1, 2, 3, and so on. Now, but we can multiply 1 over 2, that's the fraction 1 over 2 by 24 to get 12. But when we do this, does that qualify 1 over 2 as a factor of 12? No. Remember I said fraction factors. Now, simply put, we can say a factor is a whole number that divides into a given number without a remainder. Here we have the factors of 30 listed. Now you can see we have these pairs of numbers as the factors of 30. When we multiply any of these pairs, we get the number 30. So we call 30 the product of these factors. Now let's move on in this lesson to see how we find factors. Finding factors is quite easy. We have an example. The example says find all the factors of 20. Now the first thing to do is to start at 1. Now 1 multiplied by 20 gives us 20. So for example, when you have any number, you start by 1. This is like a guiding rule. 1 multiplied by 20 gives us 20. So we start listing our factors. So our first factor is the number 1, and then we also list 20. Now we can move on to the number 2. 2 into 20 gives us 10. So 2 multiplied by 10 gives us 20. We can list this among our factors. So we list 2 and 10. Now when we try the next number, 3. 3 into 20 will not give us a whole number. So the closest number is 3 multiplied by 6, and 3 multiplied by 6 gives us 18. That is not a solution to our problem. Now we try 3 multiplied by 7. 3 multiplied by 7 gives us 21. We have gone beyond our target, 20. So that is also not a solution to our problem. So let's leave out the number 3. Let's go to the number 4. Now, 4 into 20 is 5. So 4 multiplied by 5 gives us 20. Now, we can as well list 4 and 5. Now, recall that I mentioned that factors can be positive or negative. So you see, the negative of all these numbers are also factors. Here, we have some numbers and we are expected to find their factors. We are expected to find the factors of 15, 69, 105, and 363. Now, these factors have been listed. It is always important for us to start our listing from the number 1. Now, here are the factors of 15. 1, 3, 5, and 15. The factors of 69 are 1, 3, 23, and 69. The factors of 105 are 1, 3, 5, 7, 15, 21, 35, and 105. And lastly, the factors of 363 are 1, 3, 11, 33, 121, and 363. Now, in mathematics, we come across certain numbers that have only 2 factors. When we mean two factors, we are talking about just the number 1 and then the number itself. What do I mean? A number, for example, 11, cannot be divided by any other number apart from 1 and itself. So we call such numbers prime numbers. So, by definition, a prime number is a natural number greater than 1 that cannot be formed by multiplying two smaller natural numbers. Now you might ask, what are natural numbers? Natural numbers are simply counting numbers like 1, 2, 3, and so on. Now, among these natural numbers, there are some other numbers that are not prime numbers. That is, we are talking about the opposite of prime numbers. These numbers are called composite numbers. Also note that composite numbers have more than 2 factors. So once a number has more than 2 factors, it is called a composite number. Here we have prime numbers in comparison with composite numbers. Don't forget that prime numbers have just 2 factors, while composite numbers have more than 2 factors. Now we have some composite numbers like 4, 6, 8, and 9. It is also important for you to note that composite numbers can be formed by combining 2 or more prime numbers. For example, the composite number 4 is a combination of 2 and 2. So 2 multiplied by 2 gives us 4. And the composite number 6 is a combination of 2 and 3. For the composite number 8, we multiply 2 by 2 by 2. And then for 9, we can multiply 3 and 3 to give us 9 as a composite number. Now, let's learn something that is very, very important. Sieve of Eratosthenes. That name sounds weird, but don't worry. Before I tell you what the Sieve of Eratosthenes is, we have an activity to carry out in this lesson. Let's look at this activity. The activity says, find the prime numbers between 0 and 100. Now, to do this, we would cross out all the composite numbers by following the steps below. Now, step 1 says cross out 1 since it is not a prime number. Now, it is important to note that 1 is never a prime number. It is also not a composite number. Okay, so we cross out the number 1. Now, next, we are instructed to cross out all multiples of 2 except 2 itself. Now, all multiples of 2 apart from 2. So we have everything under 2 will be crossed out. We do all this, we cross all of them out, and then 4 is also a multiple of 2. And everything under 4, we quickly cross them out. 6 is also a multiple of 2, and everything under 6 is also going to be crossed out. And 8 as well is a multiple of 2, and we go ahead crossing out all the numbers under 8. Then lastly, 10 is a multiple of 2, and we also cross out everything under the number 10. Now, the next instruction says, cross out all the multiples of 3 except 3 itself. Now, apart from 3, we'll move on. 1, 2, 3, 6 has been crossed out. 1, 2, 3, 9. So we cross 15. 18 has been crossed. We cross 21. 24 has been crossed. We cross 27. 30 has been crossed. We cross 33. 36 has been crossed. We cross 39. 42 has been crossed. We cross 45. 48 has been crossed. We cross 51. 54 has been crossed. We cross 57. 60 has been crossed. We cross 63. 66 has been crossed. We cross 69. 72 has been crossed. We cross 75. 78 has been crossed. We cross 81. 84 has been crossed. We cross 87. 90 has been crossed. we cross 93, 96 has been crossed, and lastly we cross 99. So we go to the next instruction, cross out all the multiples of 5 except 5 itself. Now, apart from 5, we are going to cross out everything under 5. 15 has been crossed, we cross 25, we cross 35, we cross 55, we cross 65, 75 has been crossed, we crossed 85, we crossed 95. And then another multiple of 5 we have are the numbers under 10, but they've all been crossed out. Now, lastly, we cross out all the multiples of 7 except 7 itself. Now, we are not going to cross 7. The next multiple is 14. 14 has been crossed. The next multiple is 21. 21 has been crossed. The next multiple is 28. 28 has been crossed. The next multiple is 35. 35 has been crossed. The next multiple is 42. 42 has been crossed. Then the next multiple is 49. We cross 49. The next multiple is 56. 56 has been crossed. The next multiple is 63. 63 has been crossed. The next multiple is 70. 70 has been crossed. Then the next multiple is 77. We cross 77. The next multiple is 84. 84 has been crossed. The next multiple is 91. We cross 91. And then lastly, 98 has been crossed. So with this, we have successfully crossed out all the composite numbers. That is, all the numbers that are not prime numbers. Now, after this exercise, you realize that we have 1, 2, 3, 4. I'm actually circling the prime numbers we have. We have 4 so far. We have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. The sieve of Eratosthenes is a method we use to find out all the prime numbers between 0 and 100. By our activity, we have found out that there are 25 prime numbers. This method was developed by a Greek mathematician, Eratosthenes. We just learned about prime numbers. But this time around, we want to see what prime factors are. Now, just like the name, prime factors. There are factors that are prime. Recall that we said a prime number is a number that has only 2 factors, that is itself and 1. So any factor that can only be divided by itself and the number 1 is a prime factor. Here we have an example. The prime factors of 15 are 3 and 5, because 3 multiplied by 5 gives us 15. Now, we have seen that 3 and 5 are factors of 15. But 3 and 5 are also prime numbers. So 3 and 5 are the prime factors of the number 15. One of the methods of finding prime factors is by dividing the number repeatedly with prime numbers. It is very important to find prime factors of a number. You must keep dividing by prime numbers, and the smallest prime number we have is the number 2. It is advisable we start dividing any given number first by 2. So we move on to the next prime number, which is 3, and when 3 can no longer divide, we move on to 5 and 7 and so on. And this is how we find the prime factors of numbers. Now, there is a name given to the process of finding out prime factors. This is what we refer to as prime factorization. That is the process of finding out prime factors. Let's see how we find out prime factors. We have two methods of doing prime factorization. These methods are the factor tree and the repeated division method. Now let's see what the factor tree looks like. But it's also important for you to know that these two methods are similar, just their appearance that has a difference. Now the number 36, using the tree method, when we have 2 into 36, 2 into 36 gives us 18. So you can see I'm having a structure already. And then 2 again into 18 gives us 9. Now you realize that the number 9 cannot be divided by 2. So we try out 3. So 3 into 9 gives us 3. And 3 already is a prime number. So it's also part of our prime factors. So we can list out the factors that are prime that we have gotten so far. We have 2 multiplied by 2, multiplied by 3, multiplied by 3. And when we multiply all this, we'll come back to 36. So these numbers are the prime factors of 36. Now, in the repeated division method, we are going to try factorizing the number 36. Now, 36 divided by 2 gives us 18. 18 divided by 2 gives us 9. And 9 can no longer be divided by 2. So we divide 9 by 3. 9 divided by 3 gives us 3. So these numbers are the prime factors of 36. Now you realize that the difference between these two methods is the appearance. Here are some examples. The instruction says, express each of the following as a product of prime factors. We have 60 and 210. Now to find the prime factors, for the first number 60, we use the repeated division method. We draw our table just like we have here. When we draw our table, we divide the number 60 by 2. 60 divided by 2 gives us 30. 30 divided by 2 gives us 15. Now, 2 can no longer go into 15, so we divide 15 by 3. So, 15 divided by 3 gives us 5. And then, 5 can no longer be divided by 3. We move on to the next prime number, which is 5. So, 5 divided by 5 gives us 1. So we can now list out all we have, all the prime factors we have, and then we have successfully factorized the number 60. Our prime factors here are 2 multiplied by 2, multiplied by 3, multiplied by 5. Now moving on to the second example. In this case, we are going to use the factor tree method. The number 210 is our number to be factorized. Now, 210 can be divided by 2. 210 divided by 2 gives us 105. So, 2 multiplied by 105 is the same thing as 210. So, on our second level, we have 2 multiplied by 105. Now, to the next level, 105 cannot be divided by 2, but it can be divided by 3. So, 3 into 105 gives us 35. So, 3 on the third level, we are going to have 3 multiplied by 35. Now, 35 can no longer be divided by 3. So, we try the next prime number, which is 5. 5 into 35 gives us 7. So, on the fourth level, we are going to have 5 times 7. Now, 7 can no longer be divided by 5. So we use the next prime number, which is 7 itself. So 7 into 7 gives us 1. So on the last level, we have 7 multiplied by 1. Now, it is also important for you to note, on this factor tree method, you can choose to write the bigger number on the right or on the left. Whichever method you use or whichever way you place the numbers, as long as the product of the numbers gives you the initial number, you are correct. So, our prime factors here are 2, 3, 5, and 7. When we multiply out these numbers, we get 210. Now, having learned how to carry out prime factorization, it is also important to note that there is a shorter way of expressing our prime factors. This is usually called the index form or the power form of expressing prime factors. For example, when we have the number 2 multiplied by 2 multiplied by 2 multiplied by 2, you realize that we have multiplied the number 2 in 4 places. We can as well write this as 2 raised to power 4, where 4 represents the number of times we have multiplied 2. This is called index form or power form. Now let's look at the number 36. These are the prime factors of 36. You realize that we have the number 2 twice. So we write 2 raised to power 2, and the number 3 appears twice. So we have 3 raised to power 2. Now an example here says express 2700 as a product of primes in index form. Now we use our tree method here. You can see we have used the tree method to factorize the number 2700. Now we can go ahead to pick out our prime factors here. And we have listed these prime factors. 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 5 multiplied by 5. Now notice that the number 2 appears twice. So we have 2 raised to power 2. The number 3 appears 3 times. So we have 3 raised to power 3. And the number 5 appears 2 times. So we have 5 raised to power 2. So this is the number 2700 expressed in index form. Now, we have learned what factors are. Recall that factors are numbers we multiply together to get another number. For example, 12 has the factors 1, 2, 3, 4, and so on. Now, when we talk about common factors, don't forget our interest here is highest common factors. Before we get to that point, common factors are factors that are common when we have several numbers and their factors listed. Let's have an example. The factors of 12 have been listed as 1, 2, 3, 4, 6, and 12. The factors of 16 have also been listed as 1, 2, 4, 8, and 16. Now you notice that the number 1 appears in both lists. The number 2 also appears in both lists. And the number 4 appears in both lists. So 1, 2, and 4 are common factors of 12 and 16. Now, the highest common factor, which is HCF, is 4, because 4 is the largest among these numbers we listed earlier on. So we can say that 4 is the highest common factor of 12 and 16. HCF simply stands for highest common factor. For the purpose of definition, highest common factor or HCF is the highest number that divides exactly into 2 given numbers. Finding HCF of numbers is quite easy. The first thing to do is to list the factors, and then we circle the common factors in the lists we've had. Next, we choose the highest of the common factors that we have identified. Alternatively, we can find HCF by taking the product of the listed common prime factors, especially when we get to the point where we can no longer divide several numbers. Now, what I mean is this. If the numbers 90 and 30 we are expected to find their HCF, we take the first or the smallest prime factor we have, 2. 2 into 90 gives us 45, and 2 into 30 gives us 15. when you look at these two numbers, 45 and 15 can no longer be divided by 2. So we take the next prime factor, which is 3. 3 into 45 gives us 15, and then 3 into 15 gives us 5. Now you realize that 15 and 5 can no longer be divided by 3, but we can have 5 divide 15 and 5. So 5 into 15 gives us 3, and 5 into 5 gives us 1. At this point, you realize that we don't have any common factor that can go into the numbers 3 and 1. So we stop and we list the factors we have. We have 2 multiplied by 3 multiplied by 5. And when we multiply that out, it gives us 30. So the highest common factor for the numbers 90 and 30 is 30. Here is an activity. We are expected to list the factors of these numbers 24, 42, 60 by filling in the gaps. Now recall, I said earlier, when you are expected to find factors, you start from 1. So 1 multiplied by 24 gives us 24. So we can list 1 and 24. The next is 2. 2 can go into 24. 2 into 24 gives us 12. So 2 times 12 gives us 24. So we can list 2 and 12. Next, we try the number 3. 3 can divide 24. 3 into 24 is 8. So 3 times 8 gives us 24. So we can list the number 3 and 8. And then the next number is 4. 24 can be divided by 4. 24 divided by 4 gives us 6. 4 times 6 is 24. So we can list 4 and 6. We have successfully listed the factors of 24. Now let's look at 42. Of course, the first thing to do is to write 1 and write 42. Now the next thing is the number 2. 2 can go into 42. So we write 2, and 2 into 42 gives us 21. So we write down 21. So we ask ourselves, can 3 go into 42? Yes, 3 can go into 42. 3 into 42 is 14. So 3 times 14 gives us 42. So we write 3, we list 3, and we list 14. Now, the next is the number 4. Can 4 go into 42? I don't think so. 5 can also not go into 42 either. How about 6? 6 into 42, I think, is 7. So 6 times 7 is 42. So we can list 6 and 7. So we have successfully listed the factors of 42. Now let's look at the factors of 60. We have 1 and 60. That's the first thing to always do. The next thing is 2. 2 can go. So 2 here, and we have 30. I think 3 can also go, right? 3 here, and then we have 20 here. 4 can also go. 4 into 60 is 15. So we write down 4, and then we have 15. How about 5? Do you think 5? Yeah, 5 can go. So we have 5 into 60 would be 12. So we can list 5 and 12. 6 into 60. 6 times 10 gives us 60. So we list 6 and we list 10. These are the factors of these numbers. Now, the next line says, apart from 1, are there common factors that appear in each of these 3 lines? Let's look at the 3 lists we have. You realize that we have 2 appearing on the 3 lines. We also have 3 on all the 3 lines. But for the number 4, 4 appears in only 2 lines. But 6 appears on the 3 lines. Do we have any other number appearing on the 3 lines? No. So we stop at that point and we list our factors. Of course, 1, 2, 3, and 6. these are the factors for these three numbers, 24, 42, and 60. So these are our common factors. Now, the next thing is to find what the highest common factor is. So the HCF of the numbers 24, 42, and 60 is 6. Now, let's look at this example. Find the HCF of 15 and 40. The factors of 15 have been listed as 3 and 5. 3 multiplied by 5 gives us 15. The factors of 40 have been listed. 2 multiplied by 2 multiplied by 2 multiplied by 5 gives us 40. Now observe that we have only 5 as our common factor, and it's also our highest common factor. So the HCF of 15 and 40 is 5. And to the second example, we are expected to find, in this case, three numbers, 24, 30, and 36. We are expected to find their HCF. The factors of 24 have been listed. 2 multiplied by 2 multiplied by 2 multiplied by 3. The factors of 30 have been listed. 2 multiplied by 3 multiplied by 5. And then the factors of 36 have been listed. 2 multiplied by 2 multiplied by 3 multiplied by 3. Now the common prime factors we have here are 2 and 3. So to find our HCF here, we must multiply 2 by 3. And 2 multiplied by 3 gives us 6. So the HCF for the numbers 24, 30, and 36 is 6. Now, having learned all this, I believe this class was very interesting. I have an exercise for you just to see how well you've understood all I've said to this point. Do well to pause this video and try out these questions. I'm sure you are done. The answer to question 1 that says find the common factors of the following, 15 and 18. The common factors between 15 and 18 is the number 3. The next instruction says group these numbers into composite and prime numbers. Now, if you choose to call composite numbers Cn, our composite numbers here are 6 and 15. And if we choose to call prime numbers Pn, our prime numbers here are 5, 7, 11, and 13. Now, the last question says, find the HCF of the following. You are allowed to use whatever method you find suitable. If you have done that correctly, the HCF between 24 and 32 is 8. Here is where we come to the end of this lesson. But before you go, let's look at all we've learned in a summary. We learned that factors are numbers you multiply together to get another number. We also learned that factors are never fractions. Furthermore, we learned that a prime number is a natural number greater than 1 that cannot be found by multiplying two smaller natural numbers. We also learned that a number that has more than 2 factors is called a composite number. We learned also that a prime factor is a factor that is a prime number. Going on, we learned how to find the prime factors of a number. We simply divide it repeatedly with prime numbers, starting with the smallest prime number, 2. Next, we learned that highest common factor, HCF, is the highest number that divides exactly into 2 or more numbers. And lastly, to find the Hcf of numbers, circle the common factors and then choose the highest of those or multiply the common prime factors. Before you leave, I have a question for you just to see how well today's lesson has gone. Here is the question. The Hcf of the numbers 24, 40, and 56 is A. 6, B. 7, C. 8, D. 9. The correct answer is option C, 8. Thank you for your time. I'll see you in the part 2 of this lesson. Bye-bye.